Hello again, AP statisticians, back here with lesson 3 of data analysis. And so in the first two lessons, it's been a lot of talk about the summary statistics, mean, median as measures of center, standard deviation, IQR, and range as measures of spread. Um, and those values carry a lot of weight, but what can be really nice is to give a complete picture of a data set and of data that's collected or however it's built through experiments or data collection or sampling, I should say, and surveying and things like that. So when we look at data visualization, what we're going to do is just go through and look at some of these graphs, but important to note that what really matters when we go through these graphs is questions about center. So center, so this would be about median or mean, if we can judge that. Spread, so this would be about IQR, standard deviation, but probably most often range. Shape, which would be skewed left, symmetric, or skewed right, which we'll get into a little more here. And then things like unusual characteristics like gaps, so areas where there's no values, clusters, areas where there's a clump of values and then not really many around it either way, outliers. So this is the thing that we look at. In fact, some teachers will use this acronym SOX, which is shape, outliers, but again, this could be gaps, clusters, and so forth as well. Center and spread. So those are the things we're really thinking about when we look at these. We'll focus a little bit on that and a lot on just kind of what these graphs are showing here in this video. So a couple things to think about. With graphs, individuals just mean the distinct objects we're talking about. So what does each dot represent, or what do the values in a bar represent, or whatever it happens to be. And the variables are the characteristics. So it could be something that has to do with height or age or eye color, or things like that, depending on the graph. There's two types of variables we'll look at. Categorical are variables that you cannot calculate. So this would be eye color, hair color, ranges of values if there's things like 0 to 2 and 3 to 5 and so on. For these, we'll often use bar charts, which we'll show here. And then quantitative would be all the numerical values. And for these, we'll use what's called a histogram, which is a lot like a bar chart, dot plot, box plot, which we've already talked about in video 1 from this unit, and a StemPlot would be the last one. So we'll get these here. The two-way table is just where we have like headers and we have the numbers. So it might be red, green, and then the other variable is tall or short or something, and there might be 10 that are red and tall and 8 that are red and short and so forth. But otherwise, these are the main 5 we'll look at here. As I mentioned already, what we're looking at here is these 4 characteristics: center, shape, spread, outliers, gaps, clusters, and so forth. So here's the first here. This is histogram. Now in a histogram, couple things to note: that the way they're labeled, you can see the way the x-axis is labeled here, where it just gives you the range of values. But you'll also see something like this more often, where the value at the beginning of the bar represents the minimum for that. So in this case, that's a 5. And then this 10 here represents the minimum for the green bar. So the 10 goes to that, the 15 goes to that, the 20 goes to that, and so on. So this blue bar is really 5 to about 9.99. The green bar is about 10 to 14.99, and so on. So that's how these work. Now, when we're looking at these, this one that I've been looking at is pretty easy to describe because we see that it's symmetric. Its median is somewhere in the 15 to 20 range, which is also where its mean would be here because it's so nicely symmetric. Its range, the lowest value we could have in this data set is 5, and the highest value we could have is really 29.99. So its range is no bigger than 25. It could also be as small as, if these values are on the inside edges of these bars, could be as small as about 15. So here you would just say the range goes from about 5 to 30. You do not need to get more specific than that, because that's an issue with histograms, is they don't give us the individual values because it clumps together the bars. Okay. Now on one like this here, this is now skewed to the right, because it drags out more. If you look at where the mode is, it drags out more to the right side than it does to the left side. So that would be skewed to the right. Now, in terms of the median here, we'd actually have to do a little more work. You can see a histogram always gives us how many there are in each bin. And so we'd actually have to figure out how many there are total here. So in this first group, it looks like there's about 8. In the second group, it looks like there's about 22. In the third group, it looks like there's about 40. In the fourth group, it looks like there's about 32. In the fifth group, it looks like there's about 22 again. And then the last group looks like there's about, second to last looks like there's about 15. And then there's about 3 here. So if we really wanted to get into this, we'd have to say, okay, there's this many overall values, and the middle number lies roughly probably in this area right here. Now we could look into that more deeply, but we could also say the median is probably in that 3 to 4 bin, and it's going to be a pretty confident estimate in this situation. The range here runs from 1 to about 6, or at least in the below 1 group to the above 6 group. And there's, again, no gaps, no outliers, no clusters. Here quickly, this is skewed to the left. Its median is probably somewhere in here. Its mean is probably way down here somewhere. So that's an area where we would not want to talk about the mean. We'd talk about the median, again, because it's skewed, and median works better with skew. But it is skewed to the left because here, when you look at where the mode is, it goes much further out that direction. And you'd say skewed to the left. Again, there's no outliers. The range is about whatever this is to about whatever this is, and so on. This here, you would call this symmetric. We actually call this bimodal because it has 2 different areas that have modes, meaning 2 different areas where the bars are higher, where the bins are higher, but those areas aren't right next to each other. So we'd call this bimodal. In this problem, the median's somewhere probably in there again. We could look into that more deeply, but most of the time you would just give an estimate. The range, of course, goes to whatever that is to about whatever that is. And again, there are no outliers, no gaps, no clusters. So that's kind of how we look at a histogram. Just a couple of other general characteristics about the histogram is the bins are connected unless there's a completely empty bin. Notice that all these areas, they are all connected. If there was an empty space, for instance, if there were 0 in this bin, then there would still be a space there for it, but it would be empty. But anytime there's in the successive bins, if there's values, then those bins are connected. There's not a space in between them in a histogram. And that just represents that the x-axis is a continuous set of values. Okay, it's not hair color, eye color, and so forth. Again, you can always get some more detail about histograms if you get into how many there are in each bin, and you can figure out exactly what bin the median is in. You could figure out exactly what bin the Q1 and the Q3 are in, but you will rarely be asked to do that. Lastly, just notice there will always be a label on the x-axis of the histogram talking about the context of the graph, and the y-axis will always just be the count, how many there are, or the frequency in each bin. Okay. Dot plots. Dot plots are a lot of busy work because there is a dot for every value in our data set. This is actually what's called a parallel dot plot. It has 1 scale but 2 groups, and you can see it has a label for each one. And it just allows us to see that this day shift is much further along the scale than the night shift is in terms of values being much higher. Um, but when you look at a dot plot,
I'm having trouble here.
when you look at a dot plot, um, you get very specific information, almost too much information. When you look at these dots, it's almost overkill. But what you can see is you get everything from some of these outlying values in each group, that the day shift has some lower outlying values, the night shift has some bigger outlying values. So when you are describing this dot plot, you'd want to spend a lot of time on those outlying values in both. Um, and say, for instance, in the night shift that there's not really any values between about 31 and 34. So that would be something that would be important to mention. So this night shift is skewed to the right because of that. This day shift is skewed to the left because of the values that go down that direction. Again, just because they're outlying values doesn't mean they aren't part of it. You'd mentioned some things about how the median is roughly in here, and you could count all these out if you really wanted to. The median here is probably pretty close to the mode, even though it has those outlying values, because there's two off to the left, but there's also these three little points off to the right too. So in terms of the cluster of values, it's pretty much in the middle there. Um, and again, you would want to make sure that you mention context in all of these. So when you're talking about these, you should talk about production downtime and talk about how it's minutes and things like that. So everything is in context here, that we would describe these about center shape, spread, outliers, and so forth. Here, this is a box plot again, no outliers in this case. This is a parallel box plot. As you can see, there's three of them. The question you'd get here is to compare the distributions. And when you compare the distributions, all you'd really say here is grade 12 has the highest median of height, followed by grade 11, followed by grade 10. You might talk about their range, that the range for the heights in each grade are roughly the same. You could figure that out for sure. I guess this one has a range of 50, and this one has a range of about 45. And this one has a range of about 45. So you could say that grade 10's range is a little bigger perhaps, but could mention that. You'd say that grade 12 is ever so slightly skewed to the right if you look median to max versus median to min. Grade 11 is definitely skewed to the left. So you'd want to say that grade 11 is skewed to the left. And you'd say grade 10 is skewed to the left. Okay, so you'd mention it again, and you want to make comparative statements. Like I mentioned, grade 12 as the highest median, followed by grade 11, followed by grade 10 in terms of height. And so you mention the context again. And then you could say other things about range. You could say something about shape for each one. Grade 12 is is a little skewed to the right, while grade 11 is skewed to the left, and grade 10 is skewed to the left. And then you just mentioned quickly that none of these distributions have outliers or really any gaps that we can see for certain, because box plots don't really show gaps at all. So that's what we've mentioned about those graphs. Here's another parallel box plot here. In this case, of course, you'd want to note that the after group has a higher median than the before group in terms of pulse rate, and probably beats per minute here. You'd mentioned the after group has one outlier, up at about 145, whereas the before group has no outliers in terms of pulse rate. You'd mentioned the range for the after group goes from here to here. So the range is about 85 to 145, so a range of about 60, while the before group has a range of just over 40. And again, range does include the outliers, so that's something to be aware of. But again, you'd make these comparative statements, and you'd always come back to mention pulse rate, and probably pulse rate in beats per minute here. So you'd mention all the context, and you'd make sure to compare their centers, their shapes, their spreads, and if one of them or both of them or neither of them have outliers or gaps or clusters. In this situation, big thing would be the difference in shape. This is skewed to the left because from the mode, it goes further to the left. This one's symmetric because from the mode, it goes both directions evenly. You'd say probably that the median here is in this 70 to 79 group, and the median here is probably somewhere right in that, right between the 70 and 79 to 80 and 89 group, probably in the 80 to 89 group, most likely. You could figure that out again by just looking at how many are in each bin. Neither of them have any gaps or outliers or things like that. And the range for exam 1 is roughly from 50 to 100, whereas the range from exam 2 is also from about 50 to 100, so their ranges are similar. And again, you'd want to mention the exam 1, exam 2, test scores, and so on. This is a new one here. This is called a StemPlot. A StemPlot is always going to have the stem can be 1, 2, 3 digits, however many, but the leaf, this is also called, the leaf is just the final digit, and that could be the ones digit, it could be the 10th digit, it could even be the 100th digit if we're rounding everything to 3,200, 3,500, 3,700, whatever it happens to be. That's why this key becomes so important. So when you see 80, that could be 80, that could be 8.0. It could be that it's 8,000. Again, if this is the thousands and this is the hundreds, and we would just have to round. Notice that it'd be pretty tough to do things where we don't round if we have a bunch of digits. Like we couldn't create a StemPlot where we have 8,037 and then 8,126 and then 8,538. We would need a bunch of rows to this StemPlot. So we do some rounding. But again, what we end up spending a lot of time on is describing this. And what StemPlots do a great job of is they show us the gaps. That's a big gap there that we'd want to mention. And again, this is in final sale price. So there's no values. And if we look at the key, 80 is 80. So this would be there's no values in the 110s to the 140s. There's also a gap in the 40s. The median is probably somewhere around the 60s and 70s there. And it is skewed to the right because it has more length to the highest value from there than it does from the lowest value. So if you think about just turning this sideways, it probably looks something like that, where it's skewed to the right. If you don't have a key, that would not be a full credit situation. And again, you do need to label here. But here you'd say skewed right, median in the 60s to 70s. The range goes from 34 to 150. So the range there is 116. You'd mention that. And you'd want to mention those gaps and that maybe even that 150 is an outlier. As you see, when you skip over that much space and you have to include this space here, even though there's no values, because that's what gives us the shape, you may mention that 150 is an outlier, or you could verify it here for certain. But you'd probably be okay on a timed test to just say 150 is most likely an outlier. This is what's called a back-to-back StemPlot. And in a back-to-back StemPlot, what we're doing is just showing two different groups. So this is the same stem, but then they each have their own leaves. So for instance, this might be 49 in the Monday section. Obviously the key is missing here. And this would be 62 in the Wednesday section would be the minimum. And again, what we'd do with this is we'd compare shape and center and spread. Obviously there's no gaps here, but the medians of these two, so the median for the Monday section is probably a little lower than the median for the Wednesday section. They both are skewed to the lower numbers, are skewed to the left from where the medians are to where the min and maxes are. So they'd both be skewed to the left. The benefits here, again, like a dot plot, you can see all the specifics. The drawbacks are that it's busy work. Again, you have to include a lot. They don't have to necessarily be in number order like they are here, but it's a lot to include every single value. So you can't use really big data sets by hand. You wouldn't want to, at least. The orientation can be a little goofy, and that's something when you look at how having numbers go off to the right and left here can be a little different. But a StemPlot and a dot plot do the best job of providing very specific zoomed in pictures of your data. They just are a fair amount of work to create. Whereas the histogram and box plot, histogram it lumps values, but it will still show you some gaps. Box plot won't even show you the gaps unless there are outliers there. So you can see there's some positives and negatives to all of these graphs. The bar chart here, this is for categorical this is for categorical variables here. So this is, you can see the bars do not touch each other in this situation, and that's because the x-axis is not a continuous string of numbers or an ongoing set of values. These are just their own unique categorical variables. So again, hair color, eye color. This is M&M candies on the right, and last computer on the left. Your y-axis will still be the frequency. Here we don't get as much into center, shape, and spread because these aren't numerical, and you could change the shape very easily by just moving around the colors of M&Ms here on the right side or the computers on the left side. So for bar charts, it's just mainly about showing the information. But the key is to recognize that bar charts do have the space in between built in to show that it's not that continuous string, and we use them categorical variables. Here is a business connection to this as well about data visualization. I won't jump into this now, but the data visualization piece is a very big part of our course, and again goes in line with the idea of means and medians and the like to really provide that initial data analysis of data that's collected. Thank you very much for listening. As always, if you have any questions, please ask.